Alright, so today we're going to be talking about arc welding. Let's go ahead and take attendance for the end of the class. Brian, are you here?
Yes.
Alright, Courtney?
Yes.
Okay. Alright, so last week we talked about oxy-fuel welding and the uses of it and purposes, and different metals and stuff that you can weld with it. This week we're going to be talking about arc welding. The student learning outcome of this is the students will learn proper steps to prepare for arc welding and will be able to identify the different types of arc welding processes as well as how to apply them. First off, we've got small, also known as shielded metal arc welding, or most people refer to it as stick welding. Stick welding works simply by you take and you clamp one of these rods right here into an electrode holder, and that electrode holder will carry an electrical current, which whenever you touch the rod to a piece of metal, it'll spark and it'll start melting. Stick welding is commonly used for structural welding. It's probably the #1 choice for structural welding. Stick welding can also be used for welding carbon steel pipe or other pipes. Usually it's commonly used in big carbon steel pipe, like for oil lines and such. It's probably the most versatile type of welding. You can weld carbon steel, low alloy steel, high strength steel, cast iron, malleable iron, bronze, nickel, stainless steels, and aluminum. And in order to weld on different materials, sometimes you have to get a specialty rod. Like stainless steel has special rods that are designed only for stainless steel. Some advantages of stick welding are it's cheap. It can be used to weld just about any metal. It can weld a variety of thicknesses. It provides a lot of mobility. I mean, you can take and you can run 100 or 200 foot of lead to it and weld 100, 200 foot away from your machine. There's less prep work. The metal don't have to be as clean whenever you weld. Some disadvantages, there's a frequent starts and stops because each time you burn up a rod, you're going to have to get a new rod. There's more cleanup because the flux that coats the rod is going to create a slag coating on top of your weld whenever you get done. It produces a lot of smoke and fumes, so that's something to be cautious of because it could be very harmful if you inhale certain fumes or smokes from certain metals. It's not recommended for metals thinner than 1/16 inch. It's a lot easier to weld thicker metals with stick. Here's an example right here of an improper stick weld. You can see it has hills and valleys in it, and it's just very wavy. Here's an example of a proper stick weld, which has a nice even top coat to it. And you can tell that it's probably got about even penetration because there's no high or low spots. It's pretty much a solid little ripple. The next welding process that we're going to talk about is GMAW, also known as gas metal arc welding, and it's most commonly referred to as MIG welding. MIG welding is a lot different from stick welding, and most people consider it to be easier, but it's all on who the welder is, really. MIG welding is a wire-fed process. Wire is fed straight off of a spool, kind of like how a thread is for a sewing machine, and it's fed through a gun, and in that gun there's a contact tip that carries the electrical current. So whenever the wire touches the metal that you're welding on, it'll carry that electrical current and begin to weld. MIG welding generally requires a shielding gas I mean, there's other shielding gases besides CO2 and argon. You got mixture gases like 75-25, which is what I like to use. It all depends. Like if you weld in aluminum, argon it might be the better choice for a shielding gas than CO2 or 75-25 mix. Here's an example of a MIG gun right here. Whenever you pull that trigger, the wire will feed off of the spool and through the wheel right here, which pushes the wire, and it will come through the tip. Uses of MIG welding include, main use of it that I know of is for automotive. I mean, you can weld body panels or exhaust, or very good for patching holes and stuff. Another area that MIG welding is common is for agricultural repairs. If you got a quick fix that you need done, MIG welding is the way to go. It's probably the weakest of the three types of welds, but it'll still work. A lot of people like to use it for home repairs. And if you got something light duty that ain't gonna have a lot of stress on it, that'll work. It can weld mild steel, stainless steel, and aluminum. In order to weld aluminum with it, you have to have a spool gun, which will move your wire spool from inside the machine. It will be on top of the actual gun. And usually you can only hold about a 3-pound spool. Some advantages of MIG welding are it's really great for thin metals. It's continuous wire feeds. You don't have as many starts and stops. I mean, if you want to, you can continue welding until your machine burns up or until you run out of wire. There's no slag to clean up. It's a good gap filler. You pull that trigger and the wire will fill right into any gap, and it'll just help close it up easier than any other type of weld. It's simple. Anybody can just about MIG weld. Disadvantages are it's not quite as versatile. Generally, you don't have but about 10 foot of lead coming from your machine. And another disadvantage is it uses a shielding gas. And how that's a disadvantage is if you got a shielding gas that's coming out the end of that nozzle to shield your wire while you're welding, if there's high wind or if there's a draft or something, it could pull that gas away and it could cause your weld not to look quite as good. Not easy to be as mobile with MIG welding as it is with stick or TIG, because I mean, if you've only got 10 foot of lead coming off your machine, then it's kind of hard to carry the machine with you. It's not used for welding pipe because it's not got a high strength to it. I mean, it's still strong, but as far as holding pressure and stuff like that, or if you got something structural, I mean, MIG probably wouldn't be the way to go. Here's some examples of some MIG welds. A proper MIG weld is going to be right slick looking on top, like this one right here. I know it's a little blurry, but you can tell a big difference between the two welds. An improper MIG weld is one such as this one right here. It has a lot of holes in it. It's real narrow. You can tell it might not have got quite the penetration or the coverage that the other weld got. And next off we have GTAW, which is also gas tungsten arc welding, and it's also referred to as TIG welding. TIG welding uses a tungsten electrode that's held by a torch, called a TIG torch. TIG welding also requires an inert gas or a shielding gas, and an inert gas basically just means, you know, it's not really flammable. It'll help protect from maybe if you got a metal that's got a high flammability, like magnesium or something, that inert gas could protect it from catching on fire. It's most commonly used with pure argon as the shielding gas. Filler metal is usually, it comes in about a 36-inch piece of wire. You can get it in a variety of sizes. I mean, common sizes are going to be 1/16, 3/32, and 1/8 inch. And TIG is also an acronym, just like GTAW is, and TIG basically stands for tungsten inert gas. Here's an example of what a TIG torch looks like. You got your little rod right here, which is going to be your tungsten. And that tungsten fits in between all this other stuff. First off, whenever I put my torch together, I like to go ahead and have my collet body hooked on. Go ahead and screw my gas nozzle on. Not all the way tight yet though. I like to drop my collet in there next, and then I like to put my tungsten through that collet and push it on through till there's enough stick out. And then you screw your back cap on and go ahead and tighten up that nozzle again, and then tighten up that back cap until the point where your tungsten won't slide back and forth freely. TIG welding is very common for welding pipe. I mean, you can do automotive welding with it too. It's very common for doing roll cages and such, maybe even chassis. It's also used to weld stainless steel in the food industry. TIG welding can be used to weld the following materials: alloy steels, carbon steels, stainless steels, aluminum alloys, beryllium alloys, copper-based alloys, nickel-based alloys, titanium, zirconium alloys, magnesium, chrome, and molybdenum steels. Some advantages of TIG is it's good for precision welding. Once you get that tungsten, you need to sharpen it, usually with a grinder, to a very fine point on the tip, kind of like you would sharpen a pencil. Once you get that tungsten sharpened, you can weld in really tight places, and you can get very good penetration with TIG. TIG is probably the strongest weld out of the three, in my opinion. It's not used for structural quite as much, but for pipe, whenever you want a strong weld, if you have a high pressure steam line or something, I would go with the TIG weld. It's the cleanest weld and it's the highest quality of weld. TIG welding also requires a shielding gas and faces the same problem as MIG welding. That shielding gas, if you have a draft or wind, like I said before, it can blow your gas away, cause your weld to look poor. You got to keep your tungsten sharp, like I was saying. As you weld, the more you weld, the more starts and stops you have, the duller your tungsten will get. It'll ball up on the end sometimes, and you just got to take it back to the grinder, sharpen it back to a point. TIG welding uses more consumables. You got your gas lens or your ceramic cup that goes on the front. You got your collet body, your collet, your back cap, your tungsten. Tungsten, once you sharpen it so much, you're going to have to replace it. You've also got your filler wire that you've got to include with it, and use your filler wire as needed, but some welds might take a lot of filler wire, which could become more expensive. It requires more prep to do TIG welding. TIG welding is a very clean process. Before you do a TIG weld, you make sure that you take a grinder and grind down all the surface of the metal till you see the shiniest, slickest parts. You don't want any kind of trash, any kind of rust, paint, debris, anything on your weld. And some people, it's common, they like to take and they'll use a rubbing alcohol or something to wipe down their metal before they start welding to ensure that it's clean. TIG welding is also the hardest welding process to do in a position. Now, if you got a piece of pipe and you're sitting it on a jack stand or something, you can weld all day on it. But if you have a weld that has to be made in the field and it has to be TIG welded, it might not be as easy. Sometimes you don't have a choice though. You might have to TIG weld something in the field, but just keep in mind it might be harder to do TIG in a position than it would stick. Here's two examples of some TIG welds. Here's one that I find to be improper. It's got a lot of pores in it, a lot of holes. Didn't quite get the right fusion with it. So you can tell on this proper TIG weld that there was nice even fusion. It's nice even breakdown of the metals. Seems to be very strong just from looking at it. Are there any questions? Brian, you got a question?
Which one is the most, which one would cost less? Which style of welding would be the less costly way to weld?
The cheapest way to weld would be definitely stick. It's just, you don't have to buy shielding gas. You don't have to spend time cleaning up your metal as good. I mean, you need to clean it to a certain point, especially if you're welding something like galvanized steel. You need to make sure you clear all that galvanized coating off of it, because the fumes, if inhaled, can cause extreme upper respiratory discomfort and problems. I've been around that and experienced it before. I mean, if you inhale just a little bit, it might not affect you, but if you're around it for a few hours constantly inhaling it, you'll get a real bad cough and you just have real bad chest pains. But as far as just overall cost, stick would be your cheapest, but you also have to keep in mind what might be your situation, and if you're doing pipe, it depends on what the pipe's used for, what type of pipe you're welding. I mean, all these other factors you got to consider. They also make rods that you can weld stainless with for stick, and you can weld stainless pipe with it. But like I was saying before, if you got a steam line that's got high pressure on it, you might want to choose TIG, just because you get a better breakdown of the metals. It's the strongest welder is, and you can ensure there's better fusion with the extra precision that you get.
Thank you for that answer.
Are there any other questions? Courtney, you got one?
No.
All right. I guess that's all then. Next class, we'll begin talking more about how these processes are carried out, what kind of movements you need to be doing whenever you're doing your welds, and just a general idea how to tell if your welder is going to be strong enough to hold or not. And that'll be a whole nother day that we'll have to talk about that, because there's a lot of information you need to know about whether or not your weld's going to hold, and it's very important to know the difference between a proper weld and improper weld. Y'all want to, y'all can take some time and do a little bit of research outside the classroom yourself. That's up to y'all though. I'll see y'all next time.